All right, hello students. My name is Lee Sung. I'm going to start my lecture, asynchronous class, week 6. The topic is casting and molding process. So before I start, I want to just a quick review of where we are. So this is Unit 4. So far we learned a lot of concepts. So in the uh, week 1 and 2, we learn about the introduction to manufacturing process, where we learn about the manufacturing systems, input, process, output. And then second unit was manufacturing material. So all materials are consist of an atom and molecule structure. So we learn about material itself, and then structure and its properties. And then last week we learned about the primary manufacturing process, because in the manufacturing process, we get the original resources from the nature, which is most, for example, so metal products are come from metal ore, and then we convert metal ore to a primary manufacturing product, which is metal like sheet or metal roll. And then this week we are going to learn more about the secondary manufacturing process, which is producing the final product using the primary product. So this is very important in technology education, because a technology education is learn about the technology surrounding our lives. So we are using many technology, but we don't know where those technology comes from. So that's why this lecture is very important. So, and then you need overview. So from this week I prepared two modules, casting and molding, and second is the forming processes. So next week 2, we are going to learn more about the processes, but this week we are focusing on the first two. So I prepared four objectives. So first one is list steps involved in casting and molding. And we learn about the what is molding and then what is casting. Then we learn the basic process of the casting and molding. And then there are two types of casting and molding. So one is expandable, and then second one is a permanent mold. So we're gonna compare the two types of molds, and then you will be able to explain the process of green sand casting mold. So I will explain variety types of casting or molding methods, but the green sand is a basic. So I just want to you explain the process of green sand casting and mold. And then next one is describe the solidifying method of material. So this lecture includes some keywords. So there are some keywords. I will further explain the keywords during my lecture. And then before I start, I would just want to make sure, so those concepts such as casting, molding, and forming are very complex process. So those are just engineering practice or technological practice. So you may haven't seen the actual process. So I will show you lots of like graphics or the models that illustrate the processes. So that will help you better understand the processes just rather than just text. All right, so I'm going to start with this question. So have you thought about this question? How are metal, plastic, ceramic products made of, such as like this statue, like Oriental statue, or these are cast iron cookingware, or zipper, or toilet. So those are product of metal, plastic, or ceramic. But how does how these products are made of? What are the process took place to make those products? That's the our this lecture's key question. So we are going to explore those process in this lecture. All right, so the definitions of casting and molding. So casting molding is a name of groups of manufacturing process. So and then industrial material is made of in the liquid. So this is the casting and molding. So um, the casting and molding start with raw material such as like metal or plastic or ceramic, and then to convert those raw material into our product, we are going to heat the material and then make a solvent. Then to make the final product, we use the mold. So this is mold. So a types of the shape that mold they contain the shapes of the our final product. We pour the solvent and then create the final product. Uh, this is called casting or molding process. But the casting is uh, used to refer to the metal or ceramic, but molding is plastic mainly. So casting is metal and ceramic, and molding is plastic in this process. All right, so this is the basic process of casting and molding, as I explained. Pouring or forcing a liquid material, like solvent material, that is already heated, and then into a mold cavity. This is mold cavity. So this is a hole that has a shapes of the final product that is called cavity, and allowing the material to solidify. So once we pour or force material into the mold, and then we let them cool down. That is a process of solidifying. Then extract the product, and then create, and then that's the final product. That's the basic process of casting and molding. So, but this is just a simplest model, but we are going to learn more about the complex or actual practices of casting and molding. And there are two types of molds. So one is expandable, and then second is permanent mold. So there are types of the mold. We are going to look at the details in this lecture. But the main difference is expandable mold. This is an example. These are mold, and then the characteristics are the new mold for every cycle. So what does it mean? So this molding method is just for just one time. So after this is the engine model. So engine cylinder model. So this model is produced by this mold, but this is just for one-time use. So each time we need to make this the mold sample for this one. So that is expandable mold. So there are many types of expandable mold, and then the pattern must be produced each time, right? And then permanent mold these are examples, so don't worry about these types of name of types, but we are looking at details. But the characteristics are made of durable material and multiple use. That's the key differences between expandable and permanent mold, and built-in alignment. So that's automatic. That most of permanent mold has a automatic process, like automatic machine like produce every old process. So that's more advanced one, but this is for mass production mainly. But the expandable mold is for like special product or the certain that is used to produce certain products, certain types of quality. All right, so I'm going to look at the expandable mold as I showed this name. So first one is green sand casting. So I just want to more go detail about the green sand casting mold because that is one of the most common that contain most common practice of casting, right? So the image I captured from our textbook. So that illustrates the basic process. So first of all, we need to have pattern. That pattern is the identical, has the same shapes or size to the final product, right? We need to have the pattern, and then using the pattern, we create a mold. This is a mold that is surrounded the pattern, right? We put the pattern inside, and then the outer is a mold. So we create the mold. Let's say, right? Yeah, these are mold, right? So the engineer or technicians developed this method to create this mold, and then next take out this pattern, and then they pour the solvent material such as solvent metal or plastic, like this picture. So pour the metal inside, and then they cool down, then create this final product. That is the green sand method. So some people ask me, so why its name is green sand? So that because that name originates from the wet sand or green sand, but not actually green. But some sand has high moisture, so that's why they called green sand, like the green wood, right? These are the details of green sand casting method. Um, so first of all, so let's just say this is our final product. Our goal is creating this product. All right. So the first process is making a pattern. So this pattern. So this is a half of our final product. So let's ignore the inside. So the inside is tricky. So later we can just look at about the inside. But we need to create the first part, right? So this is first part that put into the a box, and then we pour the sand around the pattern. So put the sand. That's the first, and then the second part is we make upside down this part, the upside down. That this part goes to here, right? And then we create another second part. This is because in general, so this kind of shape, we cannot make we cannot make this shape in one shot using the sand, because in the first part, after we putting like sand, we we push this top area to make sturdy or the sturdy sand structure to stick to this actual material. So that's why we split out into two parts. And then the top part is also the same, like the bottom part is here. And then we also put the sand into this part. And then, yep. And then using the ram, we push and temper this sand. And then after making the actual shapes, we put two parts. First one is razor pin, second is screw pin. So these two parts are important because in this process, I'm going to go into 11. So to pour metal into this mold, we need to have the pathway, the metal pathway. That's the screw pin. So that's why we create screw pin and razor pin. So if we pour so much metal to inside, we need to have the exit. So X is razor pin, right? Anyway, we need to have put the 2 pins, and then go back to the numbers. Go to the next. So this we can split out to 2 parts, and then this is the top. This is bottom. So this is bottom, and this is top. So after putting the pin, we can take out the razor and screw pin. Then we can create razor and screw here, and then also we are taking out the our pattern, taking out, and then we create this pattern. So that's after this we are ready. But in this example, we also created the core inside. This is another pattern like this. Inside there's a circle hole. So in this case, we put the another object in the inside, and then also it created this pathway. So once we finish this mold, creating the mold, we can pour molten metal here, and then metal goes inside, and then create the structure, this pattern, and then to make this pattern, this object, we need to pour enough molten metal, right? So the exit metal should go to here, or during the metal metal solidifying process, there could be create some gas, hot gases. So there should be a pathway to send out the gases to outside. So this razor is plays a role of the exit pathway of additional metal or gases. So, and then we taking out extracted part. That's the final product. So this is the green sand casting mold process. So this is one of the common process of casting, mold casting. All right, so this is another example. So actual picture, I got these pictures from the website. So it's the same with our model. So inside, this is a pattern. So after putting the pattern, we pour the sand, green sand, around the actual pattern, and then temper and make this pattern up and down, and then put the 2 pins. One is screw and one is razor, and then also make some space between the around the screw and then razor, and then take it out, and then once we make 2 parts up and down, and then we pour metal into this the hole like a runner, and then this is final product. So this is an example of green sand casting mold. The second type of mold is a shell mold. So shell mold is one of the example of shell mold is this crankshaft. So in the car, so this crankshaft is deliver the power from the engine to the other part, such as wheel or other parts. So this is the crankshaft. So this shell mold method developed during the World War II. So the mold form as thin resin and then sand shell on heated metal pattern. So this is the simple and high dimensional accuracy and smoother surface finishing than other methods. So let's look at its process. It's also simple, but keep in mind this is to create thin resin and thin resin and sand shell. That's why the name is shell. So this is a sand box. Put the sand, and then there's a pattern. So, but the difference is that we hit the pattern. So hit the pattern, and then we push the pattern or upside down, and then the sand stick to the pattern, and then during the process, because of the pattern is heated, so that's why the sand more easily stick to the pattern and then create a thin layer, right? So that's the difference between the green sand mold, right? And then what's the next? The next process is heating again the shell, and then after some time later, we take out the pattern from the sand. Then we can get the smooth resin and sand pattern. That is shell mold. In the practice, this process used to create this as a crankshaft or this this kind of object. So in general, so people create a two shell mold and create this like circular S shapes. So in this example, using the two shells, one and one, and then this can be a mold. And the next part is the same. We pour metal, molten metal, and then create these shapes. This is a shell mold. And I also get this example process.
First step in the shell casting process is pattern making.
Let's look at this video.
A metallic pattern of the desired shape is made in two pieces. Typically, iron and steel are used for making patterns. Besides these, aluminum is used for low volume production and graphite for casting reactive material. After the pattern is made, the mold is prepared. This is done by heating each half of the pattern to 175 to 370 degrees Celsius. This heated pattern is clamped to a dump box. This dump box contains a mixture of sand and resin binder. The dump box is inverted and the sand resin mixture is allowed to be coated on the pattern. Thanks to the high temperature of the pattern, the sand resin mixture hardens and forms the shell structured mold around the pattern. The pattern is then removed from the mold, and to facilitate this removal, a lubricant is coated over the pattern at the start of the process. Ejector pins are also used to help in easy removal of the pattern. As soon as both halves of the mold are obtained, they are assembled to form the complete shell mold. This is done by joining them and clamping them properly. The shell mold is then housed inside a flask in which further process takes place. It must be noted that the cores are placed inside the mold before the assembly. Also, the shell mold is supported or reinforced inside the flask with the help of backing materials such as shot, sand, and gravel. After the two halves of the mold are assembled, the molten metal is poured into the mold cavity. This molten metal is then allowed to cool down and solidify inside the mold cavity. As the molten metal solidifies, it takes the shape of the required casting. After the molten metal has cooled down, the mold is broken and the final casting is obtained. So this is how various components like crankshaft and other automotive components are manufactured using shell molding. Now let's move on to
all right, so this video graphically illustrated the process of shell mold.
the advantage.
All right, so next one is plaster investment mold. So the name plaster investment mold come from the this method comes from the China and Italy. They created this method to create certain products. So it's known as lost wax casting. So because it used wax, and then this process lost wax during the process. That's why it's called a lost waxing process. Also, the investment is come from the meaning to cover completely. So let's look at this process. So for the plaster investment mold, we need to have a pattern. So let's say this is an example, but this is a pattern. So our goal is create this part, right? We want to create this part. So this example is creating 6 of the pattern, 6 objects in one shot. So that's why they added 6. And then this pattern can be made of like plastic or other material or wax or mainly wax. And then after making this 6 six objects of a pattern, and we put this pattern into the ceramic sand or a ceramic shell, ceramic flask. So we call the ceramic slurry. So in ceramic, we add more little bit of water, then becomes ceramic slurry. That is bulky status of ceramic. And then after the like up and down, we create this little like a thin shell of around this object. Like this is a ceramic slurry shell, and then after that we take out this top and like this, and then we pour this molten metal. So molten metal is very hot, very high temperature, around like 220 Fahrenheit. So that this is very hot temperature. Then once the hot temperature molten metal goes into the this mold, then the wax is melted, and molten wax comes out, and then only stay the molten metal inside of this structure, this pattern, right? There was this pattern is inside here. Then after we crash out the mold, then we can get this pattern. We can 6 at one time. So the advantage of this material, this method, is guarantee high accuracy and intricate detail, because the wax, because the shell mold keep the very accurate or intricate details of the wax mold. So that's why this method can keep high accuracy. I also get this example on YouTube. I want to share this method using the video. The first part is creating the pattern. So this pattern is made of wax. This is wax mold. All right, so once the wax mold is made of, prepared, then we assemble the pattern. The person is attaching the pattern to the structure, wax structure. This structure can be a mold, will be the mold. Right, once the prepare the mold structure, then dip into the slurry. Right, this is, and then this create a thin layer around the object, and then adding some sand into the slurry. Sand will reinforces the from the hot the molten metal. Iterate the process, and then once prepared, right before the making the actual pouring metal that heat the mold. This outside is slurry and sand, inside the wax. So pouring the molten metal, and the wax is molten, and then wax comes out, and then we can get the final product. So this process is finishing the final product because this process created some number of the patterns at one time. So taking apart each object like this. Yeah, this is the process of plasma investment mode. All right. So next is permanent molds. So permanent mold can be used to again and again to cast a mold part. So this is for the mass production. All right. So for the permanent casting, so we need to prepare the material. So the material can be like slip. This one. Slip is also the same. So slip is the mix of the clay with the water. This is slip, and then also plastic compound. So those or metal. So those are the material. So material must become a liquid or semi-liquid, or melted metal or plastic. Or slip is fine particle of clay and liquid, or compounded. So these are called compound. So compounded meaning the plastic is becoming plastic is to mix of this the actual chemical, the blend of liquid or finally divided solid material. Those are compound. So the most common method of permanent casting or molding is die casting. So this is die casting is the most product the metal production or plastic production is made of die casting. So die from dies from French word, and then it's as meaning a prototype of target object and template. We call it die. So we creating die casting. So one of the most common permanent casting method and large production quantity and good dimensional accuracy, and to the automated part create the die casting. So I said most of our like goods in our daily life are created from die casting method. That manufacture most of large production mass production products are produced by die casting. So if you're a designer and then you designed a product, and then your design is tested, and then you want to product large number of the product, then your next job is creating a die. Die is a template. So this example, this is the die example. You need to create a die, and the die is a template. So this could be a lot of time to create this die. Once we created the die, we can put this die into a tool or machine, and then we pour. This is called the cavity in the die. Has a negative shape. That's called cavity, and then we pour the plastic or metal into the die, and then push using plunger, push in this side, and then create these shapes. So this is showing this process. So metal is placed first, and then plunger is forced the molten metal into the die, and then the metal is solidified, and then after they take out, eject the object. This is die casting process, and this is the die casting machine. So most of die casting is done by this kind of die casting machine. So this machine automatically perform this die casting process, right? So it's the same. So raw material, hopper, we pour like plastic or metal inside. This example will be plastic compounds. So injection ramp, that is plunger. Plunger pours the compounded material into this die. Die is mold die is inside here. We push with a high heat chamber, and heating chamber melt the compounds, plastic compounds. Then compounds goes to inside and then create the shapes of the final object. So this is the example of die casting. But I said most of plastic or metal products you can find in the Amazon or market, most of them are produced by die casting method. And then second is injection molding. So injection molding is only for plastic. So it's the same with the similar to die casting, but used to shape plastic. And then this is made for used to create toys or game pieces. So this graph I got from this graph from Technology Students, this website. I always recommend you to visit this website. Let's look at this process. As you look at this, as you see this process, so we put plastic powder here, and then push using this like plunger while heating, and then they put this like plastic powder, also called compound, and then to the mold. So mold has already has the pattern, and then create this object. This is injection molding, but injection molding is only for the plastic. And the next method is centrifugal casting. So we see this kind of pipe, aluminum pipe or metal pipe. So inside is empty. So to create this method, we use a centrifugal force. So the centrifugal force is created by spinning action, like this, just like a carnival ride. So when you ride carnival ride, our bodies tend to move the outer side, like this. This is a carnival ride. It's a center, then right. So and then this is rotate, and this object tend to have force to the outer side, like this side. So this is a centrifugal force. So this casting method use this same principle, right? So mostly casting iron pipe is created by this method. So this is the graphical model. So molten metal is poured in here and then putting into this mold. This is a mold, and then when we pour the molten metal into the mold, that rotate, spin, then automatically the molten metal stick to the outer side, goes outer side, so to create the pipe shapes. Right, this is the example of centrifugal casting. All right, so next process is slush casting. So slush casting is to create this kind of like toy. This kind of toy. It has like a hollow the metal object has only thin layers, thin shell layers. This is the final object. To create this object, we need to create this kind of spatial mold called the slush mold. So this mold has a negative mold. That means the inside is hollow. That is for the molten metal, and then pour metal into the mold. That's the first, and then after that, immediately start cooling until desired wall thickness is obtained. So after the molten metal is poured, then they start immediately solidifying the metal from the outer side, right? So the outer side start solidifying from the outer side, right? And then wait a little bit of time, and then immediately right after we pour down the inside metal, right? So after solidifying the outside, we pour down inside. Then we can have only the shell layer, thin layer, the solidified layer. So this is tricky. So we need to have like right thickness. So this is very tricky process. So just wait until we have the right thickness, then pour out the excess metal. So that's the slush casting method. And there are certain methods to solidifying the metal, plastic, or ceramic. So first method is cooling. So we use air or water to cool down. So that is a rapid cooling method. If you use water, so that's rapid, or air is like moderate speed or moderate rate of cooling. And then drying is remove solvent from the dissolved or suspended material. So ceramic use this drying method. So such as like clay pottery. So once we make a sample like clay, and then we put the heat to the clay, and after that we just dry, right? That's the drying method used for ceramic material. And then sometimes we need to have special chemical actions, so such as plaster of Paris or concrete, and some casting acrylic needs chemical action. So example is like concrete or cement. So cement need water or other material called a catalyst, then make a chemical action. So this is the third type of solidifying method. So, but in the chemical action, so once most of case, once chemical action started, then we can't stop the chemical action. So that's why we should be very careful. So, yep, this is the solidifying method. And then these are additional slides. So boundaries, like this is boundaries. So boundaries is a pattern and then mold making. So, but nowadays the boundary are mostly worked by manufacturing, rapid prototype, and computer-aided design. So using computer-aided design, we create a pattern, and then we do rapid prototyping, and then we use also casting process like metal melting, metal composition, impurity, and pour into the mold. So impurity means we take out impurities in the process, in the foundry. So most of foundry are automated nowadays. So these processes are automated, like pouring the metal into the mold and cleaning, heat treatment, inspection, automated guided vehicle using, because of for these reasons. So increase manufacturing efficiency, reducing cost, and increase the reliability in harsh environment, or release skilled manpower, as well as reduce the industrial accident damage to people, and maximize space, and improve quality. So nowadays, most of casting and molding process in the foundry are automated. All right, so this is the summary of this lecture. So our first objective was list the steps of involved casting and molding. So first one is we need to prepare a mold using like green sand or shell mold or using other method. Then prepare material to be cast or molded, such as molten metal or iron or plastic. Then pour or first material into the mold, using plunge or ram, and then allow material to solidify and extract the finished part from the mold. This is the steps, and these are steps. And then second question was second object was how the expandable mold are different from permanent mold. So expandable mold with pattern must be produced, and then new mold for every cycle. Each cycle needs new mold, right? That's what expandable mold. Sometimes expandable mold create like fewer products or high quality products, but the permanent mold needs made of durable material and multiple use and built-in alignments. So mostly permanent mold, the most common method of permanent mold is die casting. So die casting just needs a die, certain object, then die put into the machine, and then pour molten metal or plastic into the casting, and then push using plunger first, and then create this object. That is die casting. So this is an example of permanent mold that is multiple use or made of multiple durable material. But the advantage is it takes time and money to create die. That's the problem, right? So sometimes to create a small product, you need to invest lots of money to create high quality die. That's the one issue. And the solidifying method I explained, cooling and drying, and third one is chemical action, right? All right, that's it. So thank you for watching our first lecture. So I prepared another second lecture of this week, and also you need to take a test for this lecture. Thank you.